Push that rock here with Simpson math. Let's talk about improper integrals of a particular form where we have an unbounded domain. We're going out to infinity, so the domain is unbounded. And we have a nice simple rational function where it's 1 over x to a positive power. So p stands for a positive power, p is positive, okay? And I guess this wouldn't have to be 1 here. I'm just going to always make it 1, but it could be any positive number greater than 0. So if we suppose p is 1, okay, which is a number that's positive, then we have y equals 1 over x as our integrand, and the graph looks like this. And the question is, does this area expand infinitely? In other words, diverge? Or, I mean, it looks like it does visually. Or does the area actually fit in a finite space? In other words, does it converge? Okay, so that's our question. And we're going to attack it. So let's first set up a limit. This is going to be a limit problem. We're going to pick a dummy variable, and we're going to have that dummy variable approach infinity, and we'll put the dummy variable in for the upper limit of integration. And then we can integrate normally. So naturally we get the natural log of the absolute value of x. Since our domain is from 1 to infinity, we can drop the absolute value. But we're taking the limit of this definite integral as b goes to infinity. Okay, so we get the natural log. I'm going to drop the absolute values because b is obviously positive because it's bigger than 1. So the natural log of b minus the natural log of 1, and that's 0. So that goes away. Okay, so we're just looking at the limit as b goes to infinity of the natural log of b. And Dirichlet theorem, the natural log marches to infinity with dignity, meaning it goes to infinity. So this goes to infinity, the limit does not exist, and therefore the improper integral diverges. Math made simple. Simpson math.